How's it going, everybody? We're going to talk about section 1.3, Introduction to Functions and Graphs. Um, First thing I want to start out with is the definition of a function. So, a function f from a set D to a set Y is a rule that assigns a unique value f of x and y to each x and D. So what they're saying there is if you have a set D and then a set Y, so let's call this set D and this set Y. A function is a rule that assigns a unique value f of x and y to each x and D, meaning for all the elements in D, they have a unique value in y. So if this is a value in D and we put it through a function here, some sort of function box here, it's going to have a unique value in y, each of these domain functions. Okay, so a function from a set D to a set Y is a rule that assigns a unique value f of x and y to each x and D. An alternative version of this is a function is a relation in which each element in the domain corresponds to exactly one element in the range. That's exactly what I just said in the previous part. Each element in the domain goes to exactly one element in the range. So here's some examples of functions. This is a function because our domain is -1, 1, 7, and then 5. And each domain value goes to a specific range value. And no domain value goes to the same range value. So you can have a domain value go to the you can have a domain value, two different domains go to the same range value, but if the same domain goes to two different range values, then you have an issue. So here's some examples. -1 going to 1 and then 1 going to 1 would be like if a person runs in for a touchdown in football versus catching a pass for a touchdown. Right? The two inputs were running the ball and catching a pass, but they had the same output, which was a touchdown. That's okay. That is okay for it to be a function. But you could not have catching a pass for a touchdown and also not a touchdown at the same time. Like you couldn't have that. So the key here is they said that each domain value has to map to a range value, and in this one, each domain value maps to a range value, and no domain value maps to two different range values. Again, this function here, you got -1 mapping to 5, 0 to 3, 1 to 5, 2 to 11, 3 to 21. Each domain value maps to a range value, and no domain value maps to two different range values. So this is a function. What's not a function? If 7 maps to 11 and 7 maps to 13 and 2 maps to 17 and 2 maps to 19, you have two domain values that are mapping to two different range values. That is not a function. It can happen mathematically, but that is not a function in mathematics. And then domain and range. Domain is obviously all the x values or the input values, and range is all the output values, of the function. And down here we can talk about independent and dependent variables. So the independent variables are the domain because you can pick any number for the domain and plug it into your function. And when you plug it into the function, the range is the dependent variable because it's dependent upon what your input is. So we only get 49 if we input a 7. We only get 25 if we input a 5. So this is the independent value. This is the dependent value. So that should be all the terminology when it comes to functions. So from here on out, we're just going to go through and we're going to look at functions and find domain and range and evaluate them. So for this function, x squared minus 2x, we want to find the domain and range of G. So first off, if we want to find the domain, The domain is going to be like the different values of x that I can plug in. Well, I'm not dividing by anything. So I'm not dividing by anything. I don't have any like sort of special function here. So any value for x that I plug in is going to give me some range value. So I can plug anything I want in for x, and there's nothing that's going to be undefined. So my domain would be negative infinity to infinity. For the range, the range is all the possible outputs. So I can plug anything in for the domain, but do I get the entire set of numbers for the range? Well, let's kind of check this out. So a lot of times you can use a t-chart to check this out. Let's say I plug in a 0. If I plug 0 in here, I get 0. Let's say I plug in a negative 1. A negative 1 squared is 1. Negative 1 coming in here, so we end up with 1 plus 2 there. So that's 3. Okay, let's plug in a positive 1. 1 goes in here, 1 squared, minus 2 times 1, which is minus 2. That gives you negative 1. Now I plug in a 2. 2 squared. 2 squared is 4, minus 4, which is 0. So you can see that from the looks of things, the range value, the smallest possible range value number is negative 1. So my range value is going to go from negative 1 all the way up. You can see they get bigger here. 3, if I use 3 here, that's 3 squared, which is 9, minus 3 times 2, which is 6. This is just going to keep getting bigger. So our range goes from negative 1 to infinity. And we can see that in the graph here. Make sure you use the bracket on the negative 1. In this graph, this is the graph of the function x squared minus 2x, I believe. Yes. And you can see the bottom number of the range is negative 1. So this will go from negative 1 all the way up to infinity. So now they want us to evaluate g at negative 1. So if we want to evaluate g of negative 1, we can just plug negative 1 in here, which we already did. This is called g of negative 1. But now they want us to use the graph. So it says to evaluate g of negative 1, begin by finding x equal negative 1 on the x-axis. So x equal negative 1 is here. Next, move upward until the graph of g is reached. So move up, oh, hit the graph of g. Finally, move to the right until the y-axis reached. The y value corresponding to an x value of negative 1 is 3. So I go to negative 1, go up, I hit the graph, look over, 3. So you can see that my output is 3. A graph of f of x equals square root x minus 2. It says find the range and domain graphically. So if you wanted to find this graphically, obviously you graph this. And then you look and you say, all right, you can see that f of 1 is undefined. So when they said to evaluate f of 1, we can't because this function doesn't go to 1. So that's just undefined. Now they want us to find the domain and range. Well, if you look here, our domain is going to be all the x values at work. So our domain is from 2 to infinity. That's the domain. And they show that down here in what's called set builder notation. So this right here is set builder notation. And we'll talk about that in a second. Now the range, if you look, it just kind of goes on up here. So for the y values, it's going to keep on going up that direction. It's going to cover all the y values. So our range, and they have it there in set builder notation right there, our range goes from 0 to infinity. And you can see how that works graphically there. So set builder notation. For example, let's say we have the expression x, so it says that x is not equal to 1. That's how you say that. So x such that, so this line means such that x not equal to 1 is written in set builder notation and represents a set of all real numbers x such that x does not equal 1. Okay, so that's every number, every real number except for 1. Another example, y such that 1 is less than y less than 5, which represents the set of all real numbers y such that y is greater than 1 and less than 5. So it means y has to be between 1 and 5. If you look up here, this says the range is the set of y values such that y is greater than or equal to 0. The domain is the x values such that x is greater than or equal to 2. That's set builder notation. Now let's evaluate some of these functions and find their domains. So if you have y equals x squared, what can you plug into that? Well, we have no restrictions on that because you can square any number. So that's negative infinity to infinity. But the range of an x squared function, you're squaring every number. So any negative number, when you square it, becomes positive. So the only values that are going to work are all the positive numbers for x squared. So that's 0 all the way to infinity. And anytime you have any questions on these, what you need to do is make a t-chart. This one seems pretty easy, but sometimes you might need a t-chart to figure it out. This is actually y equals 1 over x. It looks like so, meaning you're dividing by x. So you just need to think to yourself, what's the only number that we can't divide by? Well, that's 0. So any other number I plug in is still good. Like I'm going to get some sort of a range value. So this domain is negative infinity to 0, and I put a parenthesis because I cannot include the 0, union 0 all the way to infinity. So this union means take this set and combine it with this set. So we're going to have all the numbers in this set plus all the numbers in this set, which is every number except for 0. So that's the domain. Now the range. Well, if you put a big number in here, this will go all the way down to 0. Like a big positive number, this will go all the way down to 0. And then a small positive number, this will go all the way up to infinity. Right? 1 divided by like 0.00000001 is going to like be a huge number. And the same thing's true for negative small numbers and negative big numbers. A negative small number, 1 divided by negative 0.000001 will be a huge negative number. And then a big negative number will give you something that's close to 0. So that means that we're spanning the entire set of real numbers. So negative infinity to infinity would be the range. Square root of x. So anytime you have a square root of x, what's the only thing you can't take square roots of? Negative numbers. You can't have those. So I have to have 0 to infinity as my domain. Those are the only numbers that work. What can I get for numbers in the range? Well, if 0 to infinity is the domain, and I'm just taking the square root of positive numbers, then positive numbers are also the only things that I can get out. So then now I'm working with y equals 4 minus x. So I ask myself, what will give me a 0 in the middle? Well, if x is 4, it gives me a 0 in the middle. So I know that 4, if I make a little t-chart out here, so I plug 4 in for x, that gives me 0. What if I plug in 5? That gives me negative 1. So that's no good. What if I plug in 3? 3 is going to give me square root of 1. If I plug in 2, I get square root of 2. And you can see that this number continues to get bigger. So 4 is the largest number that this could be. Negative infinity is the smallest. Because if I plug in a negative, this negative and that negative will cancel to be a positive, and then that's a positive number underneath the square root. So negative infinity to 4. What are the possible values that I can get? Well, you can see 0 is the smallest number, and then you can see these are just going up. So it's still 0 to infinity. Now let's look at 1 minus x squared. So 1 minus x squared, make another t-chart here. Let's see here. If I plug in a 1, that's going to give me 0 in there. If I plug in a 0, that's going to give me a 1. So I get square root of 1, which is 1. So square root of 1, which equals 1. If I plug in a negative 1, I square the negative 1, it's still 1, so that gives me a 0 again. Can I plug anything else in there? What if I plug in like a... Let's move this chart over a little bit. So this is just continued. Let's plug a 2 in. That's going to give me 2 squared. So 1 minus 2 squared is 1 minus 4. That's negative 3. That doesn't work. And so negative 2 is not going to work either, because that'll give me the same thing. It'll give me minus 3 again. That doesn't work. So it looks like my range value goes from 0 to 1. So, my range value, you can tell, goes from 0 to 1. Those are the only possible numbers I can get there, something between 0 and 1. And then my range value, or my domain value, ranges from negative 1 to 1. And I figured that out by using a t-chart. So anytime you need to figure out something, figure out a domain or range, use the t-chart. So now we're going to graph some graphs here. This is the absolute value graph. How do you think we're going to do that? Provide the chart values. So we're going to say x, y. I'm going to start with, if it's just x, I'm going to say negative 2, negative 1, 0, 1, 2. Negative 2 goes in there. Absolute value negative 2 is 2. Absolute value negative 1 is 1. Absolute value of 0 is 1. Or of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So negative 2, 2 here. Negative 1, 1 is there. 0, 0. 1, 1 is here. And 2, 2. And we knew that this was absolute value is going to give us a V graph, because we've graphed those before. Y equals x squared. I'm going to do the same thing. Make a t-chart. I'll do it down here because I don't have a lot of room. But negative 2, negative 1, 0. I'll make some other values right here. 1, 2. So negative 2 squared is 4. Negative 1 squared, 2. 0 squared is 0. 1 squared is 1. 2 squared is 4. So negative 2, 4. Negative 1, 2. Oh, what am I doing? What? Negative 1 is not 2. Duh. Negative 1 squared is 1. I know better than that. And 0, 0 is here. 1, 1 is here. And 2, 4 is here. So this is the standard x squared function, which is a basically like a U, with its domain being all reals, but its range being from 0 to infinity. Same thing with the absolute value. Domain is all reals, range is 0 to infinity. So now we do x cubed. Make a t-chart here. Negative 2, negative 1, 0, 1, 2. Negative 2 cubed is negative 8. All right, negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8. Negative 1 cubed, negative 1. 0 cubed, 0. 1 cubed, 1. 2 cubed, 8. So negative 2, 8. Negative 8 is down here. Negative 1, 1's here. 0, 0 is here. 1, 1's here. And then you get 2, 8, which is there. And you'll see you have this function. It's reflective about the origin. So this reflects around the origin. And what is the domain and range values? Well, the domain value is going to be any number that you want to plug in. You can plug anything in. And the range value, you can get anything out. So this is negative infinity to infinity for the domain, negative infinity to infinity for the range. Okay? Vertical line test. So at the beginning, we talked about what functions were and were not. There's an easy way to check. So vertical line test is used to determine if a relation is a function. A relation is a function if there are no vertical lines that intersect the graph at more than one point. So I use vertical lines. And if you notice, all the vertical lines only go through the graph one time, only go through our function once. So yes, this is a function because each domain has a unique output with the range. And they don't share 2. But if I do this, and we'll pick a specific spot, if I go right down that direction, we've got -2 being 2. So that is an input of -2 here. I have an input of -2 being 2 different outputs. So -2 is 2, but -2 is also -4. Okay? We can't have that. So this is no, not a function. Okay? We can't have the same input value going to different outputs. And then we check a circle. Of course, a circle is not going to work because any line that we draw through it, like the radius or the diameter, is going to intersect it twice. And you can see right here, the input of 1 gives you 2 different outputs. So that is no for the function. So hopefully that shows you how to use the vertical line test. And then finally, let's recap this. So we can use mappings, which if you remember at the very beginning, these are mappings here. So we can use mappings to represent functions, but functions can also be represented symbolically, which is just with an equation. Numerically, which is the t-chart. This is an important thing. Graphically, which we can use a t-chart to graph it. We can also use a graphing calculator. And then we can look at domain and range and all that stuff. And then verbally, so this x squared plus 1 function, f squares input x and then adds 1 to produce output y. That's exactly what that is, and that's the verbal explanation of it. So that's functions in a nutshell. In your homework, they're going to ask you to do lots of domain and range and graphing and things like that. You should have all the tools now to do that. And if you need any help, ask me on Tuesday. So that's section 1.3, Introduction to Functions and Graphs.